In this talk, you'll learn how to write perfect code. Just install Standard, that's it. Thank you. I kid. So we'll be talking about how to use Standard and ESLint to catch programmer errors before they cause problems for your users. And in this talk, we'll also discuss how to get started with linting, as well as how to improve your linter setup if you already are linting your code. So I'm Feross. I work on lots of projects. Almost all of them are open source. You might have heard of WebTorrent, a torrent app that works in the browser, or maybe Standard.js, which is what we're going to discuss in this talk. And I just want to say I'm really honored to be here in Vienna to speak about Standard today. I think this is a beautiful city. Your public transportation is amazing. It actually works. I'm from San Francisco, so it's really not so nice there. But anyway, let's get started. So first, just want to cover some basic terminology that I think is interesting. So what is a linter? Obviously, a linter catches bugs. It analyzes source code to flag bugs and suspicious constructs. So what does that mean? Suspicious constructs, so that's basically lines of code that might contain a bug, but that doesn't necessarily mean that they do. And the term comes from a Unix utility originally that analyzed C code. In fact, that tool is actually still used to do that today. What's a bug? Well, obviously, a bug is when your code doesn't work, but that's pretty broad, right? So we should try to be, I think, more specific about what the cause of the code not working is. That way we can think about how to address the root cause of bugs in our code. So let's look at the word bug as it's commonly used by programmers. So if we look at the origin of the word, some people say it comes from an old term for monster. And you can still see this meaning for monster reflected in obscure terms like bugbear, bugaboo, and boogeyman. Boogeyman's kind of a stretch there, but there's actually, I think, a better story for where the term bug comes from, and maybe you've heard it already. So in 1947, the US Navy used this electromechanical computer. It was basically just a really one of those big mainframe computers called the Mark II to perform calculations. One day, they were getting wrong results. So to fix the problem, they actually opened up the computer and found a moth stuck inside, which was causing the problem. This is a real story. So the operators removed it and pinned it on a log report and wrote the following description. First actual case of bug being found. You can see it right there. So some versions of the story say that Grace Hopper herself found the moth, wrote this message, and coined the term debug at the same time. So in this usage, to debug literally meant to take the bug out of the computer to get it working. And I like this story a lot. I think it's a great story, but there's actually some evidence that Thomas Edison used the word bug about 70 years earlier. So it's just such a good story that I want it to be true, that it always gets retold, I think, in conference talks like this one, so this is probably why the story hasn't gone away. But in any case, in both of these origin stories for the word bug, you'll notice, in the one about the bug being a monster coming from the word monster, it's like a monster comes into your code and causes problems. And same thing here in this story, you have literally a bug going in and causing problems. And the thing is, this just isn't true. If you think about when is the last time a bug in your code was actually caused by a hardware malfunction or something like coming in and making your code not work anymore. It's, there's a saying that goes, if you think that you found a bug in the compiler, you're probably wrong. It's probably just a bug in your own code. So the famed computer scientist Edgar Dijkstra spoke about how he despised the term bug since it disguised where software defects actually come from. He said we could, for instance, begin with cleaning up our language by no longer calling a bug, but by calling it an error. It is much more honest because it squarely puts the blame where it belongs, with the programmer who made the error. The animistic metaphor of the bug that maliciously sneaked in while the programmer was not looking is intellectually dishonest, as it disguises that the error is the programmer's own creation. End quote. So whenever I read Dijkstra or hear Dijkstra, I always think like, okay, down, you're just an old man, you're yelling at a cloud, you're a grumpy person. But I think he's actually right about the terminology confusion, and that thinking about it in this way is useful. So back to ESLint. What is the point of a linter? What is the point of ESLint? The point is obviously to catch programmer errors, what we used to call bugs. I'm going to refer to them as programmer errors going forward. So a little history. So JSLint was the original JavaScript linter. It was created by Douglas Crockford in 2002. That's like 16 years ago now at this point, which, in JavaScript years, that's like 100 years. Then JS Hints came out in 2010, offering more configurability, more rules, and so a lot of people switched to that for the additional configurability. Then ESLint came out in 2013, offering specifically better ES6 support and additionally style rules. So style rules are like the way the code looks, and then also flexible plugin system, which allowed developers to create their own rules. And so ESLint is now by far the most popular linter, and it's going to be the focus of our talk. So ESLint checks for these three things. The first is the most important, programmer errors. These are a correctness issue in your code. The program does the wrong thing. We never want these in our programs. They're never OK. So any of these that we can catch is going to be a huge win. We should get rid of them. The second is best practices. Best practices are about avoiding confusing code, patterns that often lead to errors. It's possible for code to be correct, but to still be very confusing and terrible. So best practices are about minimizing risk and improving the clarity of your code, helping programmers to read the code later to quickly understand what's going on. And lastly, style issues are about spacing, punctuation, how the code looks. You want a team to agree on things like tabs versus spaces, for instance, so that the code is consistent. The ultimate goal is to make the entire code base look like as if a single person wrote it. This is the standard. This is actually the same reason why newspapers have style guides. And if you read a publication, like say The Economist, you'll notice every article basically sounds the same. It sounds like there's a voice, a style that publication has. This is sort of the same thing we're going for with our code bases. It's also the same reason why we have dictionaries. We standardize spelling just to avoid the cognitive overhead as the reader to figure out what word they're talking about. We just have one spelling, one way of doing it. OK, so let's talk about the first use of a linter, the most important use, which is to catch programmer errors. So you can obviously just run your program and you try to see if there are bugs at runtime. And so this is sort of like what a unit test is testing for, or an integration test, or even QA. You basically run the code, and then you check that it did the right thing. So you can do this with literally running the program and testing it yourself, which is QA, or you can have some automated test suite. But in both of these situations, you're running the code to detect the defect. But a linter can actually help us catch these errors much sooner using static analysis. And this is good because it shortens the feedback loop. So we don't need to actually make sure that we're remembering to test all the code paths through our code in order to catch errors. So we'll just detect immediately that the code is incorrect. And we can actually look at a few examples of the types of these errors that the ESLint can actually catch. So quick quiz. Do you see a bug in this code? So raise your hand if you see it. Oh, more than I expected, but not too many. It's still not everybody. Not less than half. So it's actually tricky. It's subtle. So don't worry if you haven't seen it yet. So what's going on is the for loop is going in the wrong direction. So I is being decremented with each iteration of the loop, but the loop only stops when we get up to the number 10. So it's going to actually go forever. This is an infinite loop. So this type of bug will only be detected if your tests actually run the code, or if your users experience it in production. So this is basically code that should never appear in your code base at all. So because the stop condition can never be reached, the code will run infinitely. So let's just detect this. and just make sure it can never happen in our code base. Here's another useful one. So in conditional statements, it's very, you know what, actually, before I tell you it, just raise your hand if you think you see the problem in this one. OK, yeah, this is a little bit easier, but it's still surprising. It's easy when it's on a slide like this, but it's surprisingly easy. You probably have experienced this yourself if you're not using a linter. This is actually a pretty easy mistake to make. In conditional statements, it's easy to mistype a comparison operator, such as double equals or triple equals, and to accidentally use an assignment operator, which is the single equals that you see here. What it's going to do is assign the string manager to the property job title. And so then the entire expression will turn into the string manager, which is going to be evaluated as truthy. So this if statement will always run. This is hard for a human to spot, but it's trivially easy for a linter to detect. Here's another one. Raise your hand if you see the issue. OK, starting to get some more hands coming up. But yeah, it takes a second. So this is an example of something that is probably the result of someone refactoring the code or some kind of copy-paste that went wrong. But what you see here is the parameter, the third argument to the function a is actually duplicated. This is an example of something, in my opinion, that should have just been an error in the language spec. But unfortunately, it's actually allowed to do this, so you're not going to get an error unless you're in strict mode, which will then turn this into an error. But in any case, what happens here is if you have more than one parameter with the same name in a function, then the last occurrence of it's going to shadow the preceding occurrence. So that means that basically you'll get the third argument, but the third argument will be the value of a, but you won't necessarily know this. OK, so let's catch this. Let's just prevent it. Here's one more. So this rule enforces comparing type of expressions to valid string literals. So what this means is that type of, basically, it can only return one of 5 or 6 possible strings that tell you the type of the variable. And so let's just make sure anytime type of appears in our code base that we're comparing the result to one of those strings that we know it must be. If we compare it to anything else, then that expression will always be false. So this is almost certainly an error. OK, so this one's kind of subtle. I like this one. This might surprise you. So in the first example of the regular expression there, you see the literal regular expression is between the two slashes. This is actually an invalid regular expression because we're opening a character class, but then we're not ever closing the character class. And so this will actually be a syntax error. But if you use the regular expression constructor, like you see in the bottom 3 examples there, then because the regular expression is in a string, the regular expression constructor will only throw a syntax error when that code is actually executed, which means that you might not know until runtime that this is going to be an invalid, this is going to throw an error 100% of the time. So again, with a linter, we can detect this statically because we know that this is a regular expression, so we just look at the string and we make sure it's valid. OK, so there's literally dozens of these, and I don't have time to go through all of them right now, obviously, but they're all great to check your code with. And once you start coding with this sort of static analysis, like looking over your shoulder, you'll feel almost unsafe coding without it. It's quite nice to get you get used to it, and you don't want to code without it. OK, so let's take a break from discussing the types of things that can be caught with a linter, and let's talk about how you actually use ESLint, since I'm guessing you probably want to use it now that you've seen all these amazing examples, things that you can catch. So the first step is you install ESLint. Then you need to configure it. You create a file called ESLint.rc, and these config files can be up to hundreds of lines long. This is actually the one that Standard uses here, and it's actually over 200 lines long. It's basically setting every single rule that you want to check for. So if you don't want to decide each one of these rules one at a time, you can extend a shareable config, which lets you inherit a bunch of good defaults. So standard has one of these that you can install. So if you install ESLint config standard, then your ESLint RC file can just be as simple as this. It can just say extends standard. That's it. You'll get all the rules inherited automatically. This is really nice. There's also a few other alternatives that you can look at. So Airbnb has a style guide as well as Google, and they're both quite popular as well. It doesn't matter which one you choose. Just pick one and stick with it. One thing I must mention about ESLint RC, though, is that you need to be aware of rule overrides. So inside the ESLint RC file, you can add a property called rules, and you can override the rules that are defined in the shared config that you extended. So this is nice sometimes, but beware, because it means that potentially that team members on your team will redefine the rules they don't like and change them to be their own preference, and so you can have a little bit of bike shedding going on. So why use standard? This is where standard comes in, and this is where I think standard really shines. So standard is more than just a shareable ESLint config. It ships a command line program that you can actually run directly. So you'd run this instead of running ESLint. And it comes with the same 200 pre-configured ESLint rules, but it bundles them up into a single command line program that you run, and you can just add that to your test suite. So here's how you would use it. You just install it, and then you just run it. And you'll get output like this that tells you whether your code passes or not. So I think this is the quickest, easiest way to get up and running with a linter if you don't want to install multiple packages, you don't want to figure out the configuration of every single rule. You can just do this, and you'll get some good defaults. Some rules can also automatically be fixed. So you can run standard with a --fix flag, and then whatever errors that are in there that are automatically fixable, we'll just rewrite the code and make it correct. And then you can also add it as a dev dependency, and then add it to your npm test command. So then you just throw it there before your normal tests, and it'll just catch additional errors right there, nothing to configure. And I don't want to turn this into too much of a sales pitch, but just some stats and some things about standard. So there's over 1 million downloads per month. Pretty vibrant community, I would say. And there's editor plugins for every single editor, so you can just install a standard editor plugin, and then you'll just get the linting right there in your editor, almost like an IDE. It's also built into the WebStorm editor by default. It's just you go into the preferences, and you can just turn on standard linting. Cool. So I think you should be using something like standard or ESLint in your code base, and you might already be doing that. But I just want to go a little bit into now some of the trade-offs between whether you should think about using ESLint directly or using something like standard. So I think using ESLint directly is a totally valid choice, but just be aware of a couple of gotchas before you do so. So the first I mentioned a little bit. I mentioned earlier. It's beware of bike shedding. So some teammates on your teams and projects will propose rule changes to suit their personal coding style. And now suddenly your team is debating the pros and cons of tabs versus spaces for the next few days or weeks or months in your issue tracker. So I think when it comes to issues like this, the less important they are, the more and the more subjective they are, the more people have opinions. And these kinds of debates can suck up a ton of time for little to no benefit. So when it comes to these types of decisions, standard just tries to pick something, it tries to be reasonable, and you can just move on. And so when these debates happen, they happen on the standard issue tracker, not on your issue tracker. So we bike shed the issue once and for all, we put it into standard, and then we're done. So you basically are outsourcing your bike shedding to me and the other standard contributors. You're welcome. Now, if you want to use ESLint directly, that's fine. I will recommend that. Actually, I heard a story about the one teammate on one of my friend's teams who's saying that he basically, anytime he sends in a pull request with like a lot of changes, if the linter's not passing, he'll just go in and change the rule and sneak it into this pull request with a bunch of other changes. So maybe you know someone who does that. So really, you want to lock the file down and make it much harder or impossible to change it. Another thing to be aware of is duplication. So if you have multiple repositories that you manage on your team, you don't want to check a giant multi-hundred-line configuration file into every single repository. So at the very least, I recommend you make a shareable config, and you publish it as an NPM package, and then you just make every single one of your repos depend on this package. That way, when you want to update the configuration, you just update it in one place. It's a really annoying and huge headache to keep this multi-hundred-line file in sync across multiple repos. OK, so we mentioned that these were the three categories that a linter sort of helps you with. Now that we've talked about how to actually use ESLint or standard, let's talk a little bit about some of the best practices that it can help you with. We talked earlier about the programmer errors. So remember, best practices are about avoiding confusing code, patterns that can often lead to errors, but code that can still technically be correct, but terrible. So here's another quiz. What do these expressions evaluate to? OK, raise your hand if you think you know. I think I see 0 hands. Exactly. Someone, there's a smarty pants over there. So these should probably never appear in any code base, honestly. These are using the double equals operator, which is very confusing. So it turns out they're all true, obviously, right? There's a whole JavaScript talk filled with examples like this. It's really hilarious. I recommend looking it up if you haven't seen it already. It's called WAT. Don't try to memorize these rules. Long story short, just use a linter to avoid the problem entirely. So in JavaScript, this is something you probably already know, but it's considered good practice to use the triple equals instead. This is the type-safe equality operator. So it ensures that both sides of the comparison are the same type, which prevents the confusing typecasting from happening. Now, standard tries to help you write good code, but it doesn't want to get in the way by being too pedantic. So the focus is on preventing obvious errors. So if you want to use the double equals null shorthand to test whether a variable is null or undefined, then standard doesn't treat this as an error because it's a common JavaScript idiom. So if you see, if there's any situation where it's like, we can make an exception to a rule because it's a commonly used thing, we'll do it. We're pragmatic. So double equals null means either null or undefined. OK, this is another quiz. Do you see the error in this code? So this is actually C code, but it should be possible for you to figure it out. OK, we got one. Couple more. OK, a couple more. OK, but still not that many people. So the issue is on almost at the very end, the second to last if, we have 2 goto statements. And so this was actually a bug in Apple's SSL implementation from a few years ago. And this is an example of why you should never omit curly braces for if statements that go onto multiple lines. This was called the goToFail bug, and it led to SSL not working correctly in certain situations, which led to wild insecurity with not actually verifying that a certificate's correct in a web browser. So what happens is, so if you look at this right here, what happening is that the second goToFail is actually not in the if, even though it looks like it is. It's actually doing this instead. This is because with an if statement, you're allowed to put it on a separate line if you want to, but it only will include one expression. And so even though that looks like it's inside the if, it's not. It's going to run like that. So we can, again, lint for this. So it's not necessarily incorrect. This first while statement here is not necessarily wrong. It's just risky, because somebody might come along later and add a second expression after that baz function call, and think that they're including it in the body of the while loop when they're not. So once again, standard is pragmatic, so it doesn't want to get in the way if there's a common community pattern that doesn't introduce significant risk. So omitting the curly braces for a single line if statement is totally fine, as long as you put that expression up onto the same line as the if. So if you see in this first example here, this is a common pattern you'll see in Node.js, where you see the callback first pattern. You might check for an error and then return or throw or call another callback right there on the first line. That's OK. But if you put it on the second line, that's considered risky. Cool. So I don't have time to go into too many more of these examples. So just going to mention a few final tips that you can think about. So like I mentioned before, even if you don't use standard, that's fine. If you want to use ESLint directly, that's fine. Maybe your team has their own style. Maybe it's too disruptive to change to something new. Your habits are ingrained. That's fine. I just recommend one thing. Wrap your custom ESLint rules into a package. That way, all your repositories can depend on that package to reduce repetition. And you raise the barrier a little bit, making it harder to change the rules and harder to waste time debating them. And also, consider using a command line program. So if you want to wrap up all your rules and then export a binary like Standard does that you can just run, you can do that. Standard actually has a dependency called Standard Engine. And this basically just lets you point to your rule set and then expose a binary, like a command line program that you can just run. And so you can actually create your own standard if you really want to. Yeah, if that's what you need to do to make, to satisfy your team, that's fine. And I just want to mention like a quick thing about Prettier. So Prettier is another project that does similar things as ESLint, and it's gotten a lot more popular in the last year. So I want to just mention it. So Prettier is pretty great. It formats your code to a consistent output. It's sort of like a Go format in the Go language. But out of the three things we talked about that ESLint can do, Prettier is only handling the last one, style. It doesn't catch programmer errors or enforce best practices. It's just taking in your code and then spitting it out in a nicely formatted way. So I think you still need a linter. And I think that Prettier and ESLint work well together. You can run your code through ESLint, and then if it passes, you can put it through Prettier if you want. And you can just do that like one command after the other. And so then you get the best of both worlds. And one last thing before I go, I've been working full-time on open source for the past 3 years, but it's not sustainable. So a few months ago, I launched a fundraising campaign on Patreon. And the goal was to get enough support to continue working on Standard and the other 100+ NPM packages that I maintain for at least a few days per week. So if you like what I do, consider becoming a supporter. Thank you. So I think we have like a bunch of time for questions.
Yes, question time. OK, so they want to know.
Are you serious?
Are you a tabs or spaces kind of guy?
So I mean, Standard uses 2 spaces is the rule, and that's just because it's like by far the most popular pattern in the JavaScript community.
All right. Why Standard ESLint and not a static type checker like TypeScript or Flow? Or how would you go about combining them?
Yeah, so I think so a lot of the reasons why you want to use a linter like ESLint, is for that additional static checking that you get before you run your code. So it's a great question because having static types gives you a similar level of assurance, that you can just detect an error before you even run it. And so that's a great question. I think like TypeScript is really great, so is Flow, and they actually work well with these tools. So one thing you have to be aware of, though, is that when you're writing TypeScript or Flow and you're including the inline sort of type declarations, that's like not actually part of the JavaScript language, and you're writing another language basically, right? So ESLint can't actually parse this non-JavaScript language. So what you need to do is you need to include a plugin, and then that code becomes parsable by ESLint. So there's just like one extra step and the standard README explains how to do this. It's pretty easy, but you just have to remember there's that one extra step because the code you're writing isn't actually parsable as like proper JavaScript, if that makes sense.
Cool, cool. What's your opinion on prettier?
Oh yeah, so I mentioned that a little bit in the talk. So I think prettier is pretty great. It definitely overlaps a little bit with what standard is trying to do. I mean, standard does have automatic fixing, like I mentioned, standard -- fix, and that's also included in ESLint as well. And that can do a lot of the things that prettier does. So, say you use tabs, it'll change them to spaces. It will, indent everything correctly. But it can't fully, it doesn't fully produce a consistent output like prettier does. That's because the -- fix flag is basically just saying anytime there's something that's like incorrect, it changes it to be acceptable. But that doesn't necessarily mean you're going to always get the same thing, right? Whereas prettier just says like there's only one way of stylistically doing things, and so it'll rewrite valid code that standard is okay with to make it always look one way. So the first time you run prettier, you're going to get a bunch of code changes throughout your code base that are going to need to be committed, and it can be noisy the first time you run it. But I think it's, like I said, I think it's a great tool, and it's very complementary.
Cool. Which standard would a person use or extend in React?
What standard would they use for what?
React.
For React. Well, you can use ESLint or standard with a React code base. That's totally fine. There are additional rules that you can add if you're using React to test for additional things. So standard does check a bunch of things about JSX, but it doesn't have opinions about React specifically. That's because you might use standard with a different variant of React, like say a Preact or something like that. And so we don't want to assume that the JSX you're writing is going to work with React specifically. So we'll test things like the indentation is correct and so on and so forth, but we won't say say enforce that you're doing prop types or something, because that's like a React specific thing. So if you want to, you can layer in those additional rules with your own ESLint config.
Okay, let's say you had an old project. What's the best way to ESLint that?
That's a good question. So if you have an existing code base and it has a bunch of just it's all over the place, and you want to introduce ESLint or standard, then it can be kind of intense to just do it all at once, especially if you use the automatic fixer. It'll just change everything up. And then it becomes hard for a code reviewer to make sure that that it hasn't it shouldn't change the behavior of your program, but you want to double check. So what I recommend is you can, and there's not an easy sort of automatic way to do this, but what I would do is go into the ESLint config that standard provides, that 200-line config file, and I would just copy out say 10 rules into your own ESLint config, and then fix just those. So run the automatic fixer, and it'll just fix those 10 issues, which makes a much smaller set of changes. And then I would send that in as a pull request to your team for your team to review, and then do that over and over again with different parts of the rules until you've fully transitioned the code base over. But start with just a few changes at a time. So say, okay, guys, we're all going to use triple equals throughout. Okay, let's just do one pull request to fix that issue, and then you can just progressively fix issues until you've done the whole thing. And then at that point, you can just delete the ESLint file and just use standard.
Okay. Is it possible to add standard and ESLint to a CI/CD pipeline like Jenkins and visualize the results over time?
Oh, interesting. Not that I know of. To visualize the results over time, yeah, I mean, one thing that ESLint does let you do is make rules that aren't actually errors. They can be just warnings that get printed out. So you can still technically, if you use ESLint, you can set up the rules so that you'll still pass, but you'll print out warnings. But I don't think that's a good idea personally, because then it becomes possible for people to ignore the warnings. And so when you use standard, actually, every rule failure is an actual failure. So it won't allow your CI to pass. If you add standard to your CI, then when you visualize the changes over time, it'll just be passing all the time, basically, right? Or failing if you have a single violation.
So why do you think my IDE doesn't handle this stuff out of the box?
It's a good question. Yeah, I don't know. I mean, I think that is a good question. I mean, so some IDEs do, have opinions about, default opinions about how to code for certain languages. And like I mentioned, WebStorm has standard linting as an option. And then, there's programming languages like Go, which actually just say there's only one way. And, the programming language actually itself comes with a tool for formatting your code and sort of just put all these style debates to rest because it is the way you do it, and no one debates it because it's, built into the tool chain that comes with the language. Yeah, I don't know. Like, I've heard people actually propose ideas for, like, what if programming wasn't, like, text-based? What if you weren't operating on these text buffers, but what if you, like, had some way of visualizing the abstract syntax tree or AST of the code, and you just operated directly on that? If you could do that, then there would be no spacing or text or anything like that. It would just be like you're literally operating on the literal AST that the interpreter is going to see. And so then you could imagine like not having any stylistic things to debate at all. But that's kind of a crazy, programming idea. So I don't know. Yeah, I don't know.
All right. Do you have any suggestions on how you would go about enforcing the same lint rules across multiple projects and teams within a company?
Oh, so how to get everybody to agree on the same set of rules?
Right. So you have different teams. They're not necessarily working together. How do you make this like a standard across the company? Yeah.
I mean, this is the thing. I mean, getting people to agree is always hard. You can just sneak into their code base and add it. I think having like the CTO or the person who's like the technical, lead just decide for everybody once and for all is one way to do it. Introducing it from the very beginning of a project is also ideal because then you can just avoid the debate later. If it's just, if you're kicking off a new project, just introduce some consistent linting rules from the very beginning, and then just they'll be in place forever. But yeah, to actually like get an existing diverse, like chaotic, a bunch of different teams to work together and agree on this is like a political issue. I don't know. Yeah, it's hard. I would focus on the benefits that agreeing on one style can provide across the company. So when people switch teams, to be able to just know how things are done, to not have to relearn everything again. It makes it faster when you're, moving around a lot. I don't know.
Yeah. Okay.
Cool.
Thank you so much, Feross.
Yeah.
That was wonderful.
Yeah, thank you.